Girish. How's it going?
Oh my God, I had a crazy day. There is a new law for European Union. So if you're driving the UK car in the Europe, you have to have a UK sticker on it. Traditionally, it used to be a GB sticker, and after Brexit, it's no longer valid. So I went to a mechanic to go and change the number plates and everything. Had a bunch of other issues with the car too. So
Oh no.
I got the number plates changed. So I was driving back happily for this call, and then my number plate came loose and it fell. So there was a guy.
No.
So I had to stop. Went back to the guy. So story drama. Uh,
Yikes.
yeah,
Wait,
I know.
so can you drive? I've always wondered this. Can you drive a car from the UK if you take like a ferry or something over to mainland Europe and you just are on the opposite side of the car as everybody else and that you just make it work?
Yeah, it's pretty common. People do that a lot. It's part of the European driving thing.
No
Um,
way.
The only thing it's so weird because if you're driving in France, you're on the other side, driving on the other side. So
Right.
it's like you're having a UK car driving in the US because US and France drive in the same side. So it's always like interesting. So you're on the right side of the car.
Right. Yeah. I don't think I would thrive in that scenario. I think I'd panic.
Yeah, I know. Funny thing about cars is that like in the US, you guys don't want to use any roundabouts apparently, even though it saves a lot of lives. And like like there was a study that came out and said like, hey, nearly like fatalities can reduce by 80% by
Wow.
introducing roundabouts rather than traffic lights. In Europe, we are like fed with roundabouts every nook and corner of the street. Like there's always a
Yeah.
roundabout.
Oh my gosh. Yeah, Americans are very resistant to most things that make sense, but particularly roundabouts. They tried to do it several in my hometown, which is small. I mean, we're
Yeah.
talking like maybe 10,000 people
Wow.
living in this town, really small. Um, and people hated them so much that they started treating them as stop signs, and then they would just drive through the middle of the roundabout, like over
Wow.
where there should be like a garden or something.
Yeah.
It's just they've just like basically created a road out of it.
No way.
Yeah.
That's crazy. I found it very interesting because I drive in the US too. And when I did drive, and I find that very interesting how you guys have the stop sign, like where you have to 100% stop,
Hmm.
where that could be a roundabout, in my opinion. And I find people don't take roundabouts really well. Some expert drivers do, some people, they don't know what to do. So it's just like,
Yes. Yeah, that happens. I live in Nashville, and Nashville is like just notoriously terrible for drivers
yeah,
because most people are not from here. 100 new people move here every day. So we just have a lot of new folks. We have a lot of
wow.
tourists. And a lot of the tourists who come to Nashville are coming from like rural parts of America. So you just put like all those things together and then you give them, I think we've got like two roundabouts in town and people lose their minds. Just like
Wow.
absolutely. Anyway, jealous of that part. But yeah, the wrong side of the road, I don't think I could do it. So
Yeah, for me, I love driving, so I can suck it up, I guess.
yeah. Well, I'm glad you got your car stuff taken care of this morning. I know that kind of, for me at least, I will wait until the last moment and it just like withers and dies on my to-do list. So good on you for knocking it out.
Here I am, I made it.
Yes, you made it. And this is a fun episode. I'm going to read a historical event that happened on this week in tech history.
FORTRAN represents the most advanced coding system available today and is the forerunner of a universal coding language towards which we are working. FORTRAN permits a user to write or prepare programs in a language which is closely related to that of mathematics.
This week, the event is researchers run the first FORTRAN program. April 19th, 1957, researchers ran the first FORTRAN program. Short for Formula Translator, I did not know that. FORTRAN allowed programmers to work in a high-level language, meaning it had a strong abstraction from the details of the computer itself. So we'll get into that, but it essentially means, like closer to natural language. So this is opposed to low level, where functions and commands are more structurally similar to the processor. High-level languages are much more natural language driven in nature than their predecessor. So FORTRAN has been used for over 6 decades in computationally intensive areas such as numerical weather prediction. I did not know that. Finite element analysis, computational fluid dynamics, geophysics, computational physics, crystallography. Don't know what that is, and computational chemistry. These are just like side note. These are all subjects where if somebody studied them in college, I would be like, cool. We're not the same. We are not the same. It is a popular language for high-performing computing and is used for programs that benchmark and rank the world's fastest supercomputers. While FORTRAN has been the basis for other languages throughout the years, its own evolution has increased support for structured programming and processing of character-based data, array programming, modular programming, and generic programming, high-performance FORTRAN, object-oriented programming, concurrent programming, native parallel computing capabilities.
That's a lot of information.
It's a lot of information, but we have you here today because you can speak to some of this, and you can also speak to, like, as far as I remember, my time at Gun.io over the last 5 years, I think I've seen maybe like one request for FORTRAN come through. What's your take? Like, are you seeing there people still having an appetite for any sort of FORTRAN knowledge or skill?
Yeah, FORTRAN is like a really interesting. It has an interesting place right now in the world of tech at this moment, like 2023, mainly because the way FORTRAN is built, it's still one of the fast performing programming languages in the world.
No way.
Yeah, which means it's faster than C++. Hey, I'm on the record right now, but it is. So there are people, especially scientists, who prefer FORTRAN, and they write code in FORTRAN and execute them in supercomputers because of their calculations being too long. And it's like a best programming language to do high performance computing for scientists, very specifically around that area. So it has a lot of relevancy right now. The high level is really cool because, like, being a scientist, you don't want to know all the algorithmic, patterns and all that stuff. All you wanted to think about is like, hey, can I execute my theories and like in code, and can I get it done faster? And they tend to choose FORTRAN because of that reason. And there's no other programming language that can compete to that. So if you're a scientist, probably you will understand why. But if you're not a scientist, if you're a straight up software engineer, probably FORTRAN might not be as extensive as you would like. If you look at Python, for example, Python would have a lot more libraries. You can play with ML, AI tools. You can integrate with ChatGPT and all the new stuff. Whereas FORTRAN is like straight up code that you can run, and it's super fast, and it can make use of all the CPU power in a supercomputer to get the results you want. So I think the motive is very different for FORTRAN but there is demand and people still use it, and maybe not as a web developer, but definitely a scientist.
I'm curious. I mean, it's been 70 years, right? And we've had just incredible amounts of innovation. And I'm curious about your take about what it is about FORTRAN that has made it the benchmark for supercomputing. Is it the ease of use for scientists or just the raw speed? What do you think?
Yeah, there are a couple of features. I think you mentioned them quite a lot, like, the fact that it is out of the box. In those years when it came out, programmers wrote code directly into missions. So you need to write. So think about it, the way missions work is zeros and ones, right? So, and yes or no is the answer. Is whether it's exist or don't exist. It's like a Boolean, it's a binary. So when people have to write code, they have to think about that mindset, whether you do that. So when FORTRAN came out, it was the first high level. So it converts your regular code, like human readable format kind of stuff, into code, which is assembly that runs on the supercomputer. But the way it's built, it has its own strengths and weaknesses. The strengths are like, hey, it's very opinionated. You can't do a bunch of stuff. Like, you can't do like, for example, pointers, like the way you use pointers in C++. Pointers is a way to kind of hold memory and say, hey, keep a hold on that number while I get back to you kind of thing. So So there are a bunch of other techniques which we use today. Fortran is very, very opinionated and like structured in that sense. So the way Fortran is built that way makes it very structured for anybody who writes an average code in Fortran. Trying to work faster than you can use C++ and write a very rubbish code, and that could take a long time to execute, and it's your fault because you're driving the code wrong. Whereas if you write in Fortran, there's no way you can that Fortran like the generator would let you continue writing that code like that, so it'll stop you. So basically it's very opinionated and it's how it's run. So by nature of how you write your Fortran code, executes very fast. So there is no other alternative as good as Fortran. Fortran had so many iterations. I read somewhere there was an active community of people who are trying to bring Fortran back, to kind of like to make it very current and like work today. So Fortran, I think, has that kind of leeway, and it runs parallelly, and it has all these cool benefits of running its own way. It's a very opinionated way of doing it. Nobody has done it better than Fortran yet. So for what it does the job really well, and that's why it's really good.
Yeah, it speaks to the value of finding a niche, right?
Yeah.
I mean, the other thing is, and you can tell me how true this is, but I believe that Fortran was kind of the impetus for the if statement, which now it feels so basic to programming.
Oh yeah.
When we think about the if statement today, like what do you think the effect of Fortran introducing the if statement has had on programming as it exists today?
I challenge any programmer out there to write a program without an if statement.
Yeah, even me. I mean, I can't make a database without an if statement.
Yeah, exactly. Like there's nothing in today's conditions that programs a bunch of rules, right? And rules don't exist if doesn't exist in if, right? So it's like pun intended, all right? So, but the thing is that like if is such a valid like statement to be asking when you're writing a code, and like you check a bunch of rules whether it's true or false. Again, it comes back to the same thing. Like the way programs thinks is like whether it's true or false. So if a condition is true, then proceed. If the condition is not true, don't proceed. That kind of like thought process has really been driven into so many programming languages today. So you can never run anything without a condition in that sense. So it comes back to like even if you would take up a straight up calculator, like the like mechanical calculators or whatever, they use something called AND gate and OR gates. AND gates are nothing but if two statements are true, then proceed. OR gate is like either one of the statements are true. So if you are learning basics of computer science, the AND gates and OR gates are the ones that drives the rule. And having if statements in today's programming languages is such an influential game that Fortran has actually set forth for. So there's nothing that kind of like changes that, right? Like so it's so cool. I kudos to the creator of Fortran, like John, I think John something, but that guy is really cool. Working for IBM, was lazy to write mission level code, wrote and created Fortran, being such a cool tool. So it's really fantastic.
Yeah, and I have the same question for you as it relates to natural language, right? Like there's some programming languages today where it almost feels like it's not code, right? And of course, that's 70 years down the line, and there's been a lot of innovation in the time between. But it's safe to say that progressively, we've built on the foundations that Fortran laid as it relates to natural language and in programming languages. So I'm curious, like, what's your take on how Fortran kind of set the tone for the use of natural language in coding?
Again, kudos to John for creating something like this, because it's done a really good job in sense like, you open a bench of creativity at that level, right? Like when you're creating abstraction, like even for kids, right? When you have a stencil, it's easier for them to be very creative and use the right colors and play with it. And entry to barrier is very low when there's abstraction on the top. So making it as natural as possible helps all types of industries to depend on technology. And we see that a lot, even in gun and everywhere, right? Like every single business would require technology. How are you getting doctors to write code? How are you getting, Faith to write code and like everybody else to write code. Like, so, in order to do that, like you need to create that level of natural language stuff. And the history proves it. Like, look at today's popular programming language. Forget JavaScript. I know it's taken number one because of the popularity of it. Just below that is Python. And Python was fairly recent. But what is cool about Python when it came out is that, it was super easy to learn, and anybody who understands basic logic, you don't need to have any declarative stuff or anything like that. You can just write straight up Python code. It only takes a few days to learn Python and get coding, right? So it made it so easy, that abstraction, and having it so natural lets a lot of people to write code. And because of that adoption, today Python has the most vast library support in the world. So a lot of people can use ML stuff or AI stuff out of the box, like, which historically hasn't been possible. And this paves a new way for open source. Long time ago, maybe like 10 years ago or something like that, I worked with Python and I used a bunch of open source software to predict landslide modeling, which is kind of crazy.
Oh my gosh.
Yeah, it's kind of crazy. It's not what I expected, but I helped out a physicist in a university kind of build this model, which he had an idea to. But the funny thing is that they used that software in Nepal during the earthquake, so which was mad, and the software helped save people in the rescue effort, which was mad. Like, I was really humbled by that story myself. Like, it's like, wow, this is possible today mainly because of the adoption. So the more abstract a programming language is, the more easy for anyone in the world to come and code it. And not only just they can come and code it, they also can create open source software that makes the world of programming beautiful. Like, so you can pick and choose whatever you want, and that's revolutionary. And can you believe that it started from FORTRAN? So that's, a guy in IBM wanted to make a way to easily write assembly code, kind of turned into like today's like foundation of how we write software. And it's only going to get better and better. One day you'll sit in your computer and just type a bunch of things, and it'll understand your spelling mistakes and everything and put it into code. It'll be the future, I assume. Like, but I don't know how far that'll be. But
I would say a few months. I mean, you think about like Copilot, right? Think about all of the, especially over the last few months, kind of AI components to coding that have been introduced. It's, I think, within this year, for sure.
I love Copilot. The fact that I just write first one letter or two letters of my program, it kind of fills the gap, which makes no sense because it has all the context it's needed to kind of continue your work. So it's pretty crazy. I'm pretty impressed.
Yeah. And, that speaks to, you talked about natural language kind of broadening access to programming, but it also deepens it, right? Like, it allows for much more computationally complex programs to run.
Yeah.
And that's the foundation of where we are today as it relates to AI and ML.
Even if you think about the logic that goes into creating a complicated algorithm, there is always a better way or a lean way to do something. Not necessarily everybody's going to touch upon it, but when you have that natural languaging and there's a translator in the middle to kind of intercept that natural language code into real mission code. That's why it's called formula translator. It translates the formula, right? So it's like a natural translator. So, and that reduces everybody. I mean, like it maybe like put it this way, like everybody's going to be very efficient writing regular natural language code into mission code. So you're always going to get an efficient product end of the day. Which is crazy.
Well, you've convinced me that the first language I'm going to learn will be FORTRAN. I'm not a scientist. It's probably going to do nothing for me usage-wise, but it feels like a historic thing that I just need to know. So
yeah, it's so funny. The extension for writing FORTRAN is .f files, like C++ is .cc++, or CPP. Yeah. It's .f.
Perfect. My first initial.
Yeah, I know.
It's made for me.
Yeah.
Well, Girish, this has been so fun and educational, and I appreciate you essentially being an encyclopedia on computational history.
Oh, wow.
What an asset. And I'm also just stoked that your car is in a good place now to be on the road. So good day all around.
Yeah, thank you so much. Yeah, I'm glad everything is better and we are talking about history.
Yeah, you're like, I'm in my happy place talking about computers.
Let's talk about computers. We'll be fine until I geek out and like start writing code and showing you demos.
Next time. Thanks for listening to the Frontier Podcast powered by Gun.io. We drop 2 episodes per week, so if you like this episode, be sure to subscribe on your platform of choice and come hang out with us again next week and bring all your internet friends. If you have questions or recommendations, just shoot us a Twitter DM at The Frontier Pod, and we'll see you next week.